Okay, this part should be part 6. I think I'll just uh, continue where I left off, and that was I was talking about the wires coming from the secondary coil of the transformer, and I said that this wire is a series connection with the other parallel branch here. Okay, this is one parallel branch, and this line is the other parallel branch, come from that multiple strip that I showed you in the last video. Now, this other wire here goes to the white wire of this bulb. Okay, now there's two bulbs here, this bulb here, and okay, now the other parallel branch down here, which is right here. Now, this wire of it goes to this black wire, which goes to the first bulb here. That's all the connections there are to the load. Okay, but now these are connected in series, and that is done by connecting the black wire of this bulb with the white wire of this bulb. Okay, that's the black wire there, yeah, and the white wire here. So that's all the connections there you need. Now these wires here, 4 of them, they're 12-2 wire. From 12-2 wire, well, actually, I got it from I think a 12-2 or 12-3 wire, and I just took them out of the insulation that surrounds them. And they're better to use because they're stiffer. They're really stiff, and they would be better for 240 volt. You know, if you use 14-2 wire, then there's chances are they're more limp, and you know, like your alligator clips here could accidentally short out. So, you know, it's always better to use these. They're really stiff and never move enough. Okay, that's all there is on there. Geez, I gotta pause here for a minute. I don't know what else to talk about here. Okay, that's right. That's all I have to talk about this, except that we're pretending these are 100-watt light bulbs, and what's happening here is because we have two parallel branches, somehow we're creating 833 milliamps, and that's what is required for one light bulb. And I think it's 144 ohms for each. Yeah, I'm pretty sure it's that. So altogether is 288 ohms. So the current should be half that, 833 milliamps. So that would be 416 milliamps. But because of diagram 3 and we have two parallel branches, somehow it's sharing the current. Okay, one branch is putting out 416 milliamps, and the other branch seems to be putting out 416 milliamps. And altogether we have 833 milliamps. And because we have 240 volts at the load, which is both bulbs, okay, first 120 volts drops over this bulb because that's all it's designed for, and 144 ohms, it only takes so much current. So it takes 833 milliamps, and the first voltage drops over that 120 volts, and then goes to the next one, which would be, it would go to this black wire, go into the next bulb, but because we have 240 volts in total, we used up the first 120 volts on this, but so we still have another 120 volts to push it through this next light bulb using the same current that we used for this. So yeah, it is saving if you're using 2 light bulbs for something, you're saving 50% of the electricity. Okay, so that's what you have to do. You got to use the same wattage. I have experimented with different wattages and stuff, like like a 60-watt light bulb and a 100-watt light bulb. I haven't experimented with that yet, but I'll do it sometime in the future and see how you can get around with that. Okay, now I'll pause it and get ready to measure the voltages to prove it to you.